And so now we're going to jump right in, and we're going to basically use the same resistors, but we're going to do a 2 resistor parallel circuit. So we're going to have our same 3 volt battery, and this time my resistors are going to be in parallel. 3 volts, 4.7 kilo ohms. I'm gonna swap out. I think the 2.2 is going to work a little bit better for what I want to do. 2.2 kilo ohms. Now we're going to say my R1 over R total. We're in parallel now. 1 over R total is going to be 1 over R1 plus 1 over R2. So 1 over R total is going to be 1 over 4.7 kilo ohms plus 1 over 2.2 kilo ohms. And remember, that's a little bit of tricky calculation action. So 1 divided by 4.7 E3 plus 1 divided by 2.2 E3, and then I've got to flip that, so I got to take the inverse of that, and so I'm going to get that my R total is going to be 1.5 kilo ohms. Okay, so my R total is 1.5 kilo ohms. That means that I equals V divided by R. I've got 3 volts divided by 1.5 kilo ohms. I now have 3 divided by my answer. I'm going to have 2 milliamps. So I'm going to have 2 milliamps in my circuit. Now, before the current only had one path it could go down. The electrons only had one path it could go down. Now, in this circuit, the current has 2 paths it can go down. There's a little split here. There's a little fork in the road. So some of the current can go this way, and some of the current can go this way. And in fact, what we're going to see is that more of the current is going to go this way because the current wants to go where there's less resistance. So more current is going to go this way, less current is going to go this way. What's going to stay the same is the voltage. This point here is at 3 volts, this point here is at 0 volts, so 3 and 0. Now the voltage only drops where there's a resistor. So if this is 3 volts, 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 this is 3 volts. This is 0, 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 this is 0. So my voltage drop, that's 3, that's 0. My voltage drop is 3 volts, my voltage drop is 3 volts. So again, we're going to have a chart, R1, V1, I1, R2, V2, I2. And we're going to say R1 is 4.7 kilo ohms, and its voltage drop is going to be 3 volts. My R2 is going to be 2.2 kilo ohms. My voltage drop is going to be 3 volts. And then I'm going to use V equals IR. So I'm going to just plug some more stuff into here. I'm going to say I1 is going to be 3 volts divided by 4.7 kilo ohms. So 3 divided by 4.7 E3 is going to be 0.64 milliamps. Transfer that up there. And then I'm going to say my I2 is going to be 3 volts divided by 2.2 kilo ohms. So 3 divided by 2200, and I get 1.4, and I get 1.36, call it, milliamps. And now, not surprisingly, 0.064 milliamps plus 1.36 milliamps is 2 milliamps, which is my I total, which we just found. So we're going to have a current this way of 0.64 milliamps, and we're going to have a current this way of 1.36 milliamps. Okay, let's try it. And again, I highly recommend that anybody should try this at home. So let's clean up the surface here a little bit. Okay, so I'm going to put them now in parallel. Make sure they're all going into the same way. Get the marker out of the way. I'm going to hook this up here. I'm going to hook this up here. If you think about it, you'll understand why I don't have to hook everything up together. They already are hooked up the way that they're supposed to hook up. And so let's go voltage first, and we're at 3 volts. So I go across the battery, is trying to get my hand out of the way. We get 3.01 volts. If I go around this resistor, I get 3.01 volts. If I go around this resistor, I get 3.01 volts. Now, if I disconnect this and I want to measure just the current through that one, I'm expecting, that is my 4.7, so I'm expecting a reading of 0.64. So I hook up and I hook up and I get 0.634. Pretty good. I'm going to hook that one back into its hole, and I'm going to pull this one out. And I got to rearrange this here. And I'm expecting 1.36, so I measure and I get, I got 2, so I must have done something wrong here. I'm getting voltage that I'm getting current somewhere that I shouldn't be getting current. There's my, so somehow I'm getting the whole, how did I do that before? So let's back up and look at what I did when it was working. Well, let's figure out first off what's the total current here for the whole thing. My total current for the whole thing, right now it says I'm overloaded. So let's go up to there. 2.66. So right now it's saying 2.66 is the total milliamps. So I have a error in my calculation at some point that I'm going to have to sort of work out. Let's figure it out in my next video.